Hello and welcome to another video brought to you by RouTube. In this video, I will explore the Pearson's correlation coefficient, which is known as the R value, which students will study in Year 11 and Year 12 further maths. So a couple of learning objectives in this video. The first one is to gain an understanding of Pearson's correlation coefficient, which is once again known as the R value. And the second objective is to be able to calculate the R value Pearson's correlation coefficient using the CAS calculator. Alright, so just a bit of background on Pearson's correlation coefficient. So the Pearson's correlation coefficient is a tool that measures the strength of a linear relationship between two variables. That's almost just a definition of what Pearson's correlation coefficient is. The symbol used to represent Pearson's correlation coefficient, which I've said previously, is a lowercase r. The value of r ranges from -1 to 1, and we'll have a look more deeply in that throughout the video. If the R value, so if the value of Pearson's correlation coefficient is positive, then the linear relationship is positive. And if the R value is negative, that means that the linear relationship is also negative. Pretty straightforward there. So when measuring the relationship between two variables, the key things to look out for are in reference to direction and outliers, if there are any outliers in your data, form, and strength, which once again we'll unpack those as we proceed through the video. And when using Pearson's correlation coefficient, there are three key assumptions that need to be made. So the first one is that the data is numerical. So once again, these are assumptions. Okay, so the data is numerical. The second one is that the association is linear, which we'll unpack in a second as well. And the third thing is that there are no outliers. So we assume that there are no outliers in the data if we use Pearson's correlation coefficient. All right, so let's first have a look at direction and outliers. Okay, so two variables have a positive association when the value of the response variable tends to increase as the value of the explanatory variable increases. Now, for those people that haven't been introduced to the EV, explanatory variable, and the RV, response variable, the EV always goes on the x-axis and the RV, response variable, always goes on the y. The second dot point, two variables have a negative association when the value of the response variable tends to decrease as the value of the EV, the explanatory variable, increases. And the third and final dot point is that two variables have no association when there is no consistent change in the value of the RV when the value of the EV increases. So essentially, we have a look at these three diagrams here, these three scatter plots. The one on the left-hand side clearly has a negative association because the dots are going in a downwards fashion, okay? And the easiest way to identify the direction is always start at the leftmost point. So if we start at the leftmost point, which is this point here, from that point, the rest of the points trend downwards. So there's clearly a downwards trend, which is, as we've read, is a negative association. The middle one, we see we start at the leftmost point, but then there's all these random points. It sort of increases, then decreases, then increases again, then decreases again. So there's no consistent change in any of the values or in the RV as the EV increases. And then the final one, once again, we start on the leftmost point, which is this one down here, and then we see there is a general increase. So that would be an increasing trend, which is what we call a positive association between the EV and the RV, so between both of the variables. Now, in most cases, as soon as you look at a scatter plot, you'll be able to identify whether it's positive or negative straight away in most cases, but some will be a little bit trickier than others. All right, now we move on to form. And when we talk about form, it's either linear or non-linear. So if the points in a scatter plot appear to be as random fluctuations around a straight line, which we can see in the left diagram there, the scatter plot has a linear form, thus stating that the variables are linearly associated. All right, so it's all about a straight line, which is sort of the whole meaning of the word linear. Next dot point, if the points in a scatter plot appear to be as random fluctuations around a curved line, so we see the difference between a straight and a curved line, the scatter plot has a non-linear form. So we can clearly see, if we have a look at this left one, there is a clear straight line that the points sort of fluctuate around, some above, some below, but the general trend is sort of in a straight line. Then there's a clear linear association between the two variables, whereas this one here on the right, we can see this clear non-linear, this curved line that the points sort of fluctuate around. And again, some above, some below. All right. So if it's around a straight line linear association, if it's around a curved line, then it's a non-linear association, because at the end of the day, linear just means straight line. All right, now we turn our attention to sort of the main part of the video, which is to classify the strength of a linear relationship using the correlation coefficient. So using the R value. So essentially what this means is once you have your R value, once you've calculated it, which we'll go through in just a second, classifying it should be fairly straightforward if you have this table at hand. So if you are studying for a SAC or an exam, or even if you're just writing some notes down, I do highly recommend that you have this written down in your notes, in your reference, just to make reference to as you're completing your SAC or your chapter questions or during the exam. So essentially what it means, if you calculate the R value to be between 0.75 and 0.99, that will indicate a strong positive linear association between the two variables. And you can just make your way down throughout the table. So we'll go to that white one there right in the middle. So if the R value is between negative 0.24 and positive 0.24, then there's actually no linear association between the two variables. So like we said before, that R value is just a measure of the strength between the RV and the EV. So the response variable and the explanatory variable. So once again, it is a measure of the strength between the two variables. And you'll see it goes from 0.99 all the way down to negative 0.99. And that bottom part where it says if the R value is a positive 1, which you probably won't see too often, but it's good to know anyway, and we'll sort of have a go at what that actually looks like in a second. So if the R value is positive 1 exactly, this indicates a perfect positive linear association. And then on the other end, if the R value is negative 1, this indicates a perfect negative linear association. So once again, the R values range from negative 1 all the way up to positive 1. And just having a look at what we sort of just spoke about in terms of the R value. So we can see in the top left-hand corner, there's no linear association between the EV and the RV, okay, because there's just a random scatter of dots. There's no indication whether it's positive, negative, linear, non-linear. It's sort of just random dots all over the shop. So that would be a rough indication of, or rough estimation of no linear association. So the R value would be about 0. Okay, moving along to the right, perfect positive linear association. We spoke about that one before. So the R value would be positive 1. So you can see that's in a perfect straight line, a perfect positive straight line. So starting at the leftmost point, and there's an upwards trend or a positive linear trend. Moving along to the top right, we've got a perfect negative. So essentially just the opposite of a perfect positive. So a straight line, but a downward straight line now. So that would be an indication of the R value being negative 1. Now, once again, you probably won't see positive 1 and negative 1 so much, but it's good to know anyway. Moving along to the bottom left, where we've got a moderate positive association. So if your R value is positive 0.5, there's still an upwards trend, still a positive trend because the R value is positive, but you see it's not as strong as the positive 1. And then also the final one, weak negative. So you'll see the relationship is not as strong and it is negative. So start at the leftmost point and then the points go in that downward trend from left to right. So that's just a rough indication of what some of the scatter plots will look like depending on their R value. Now, again, these are just a couple. There's obviously every value between 1 and negative 1 that the R values can actually take on. All right, so now let's have a go at actually calculating Pearson's correlation coefficient for this piece of data. And we need to give our answer correct at 2 decimal places. So for those of you that have found or performed a stat calculation on the CAS, this should be fairly straightforward to you in terms of finding the 5-figure summary and other things like that, including mean and your standard deviation. If you haven't, we're going to go through it slowly, so don't panic too much. So just to save a bit of time, I've already entered the data values in, and then we perform our stat calculation. So because we are in the business of doing bivariate data at this stage, that's sort of the only difference between bivariate and univariate, is the type of statistical calculation we perform. So we hit menu, statistics, stat calculation, and then you would have hit one variable when you're doing univariate, but because we are looking at two variable statistics, we then press on two variable stats. And that'll bring up this little box. And then the only two things that you need to change are those two top boxes. So essentially what it's telling you, or what it's asking you, is what's your X variable? So what's your explanatory variable? So as soon as you press the drop down, now mine's pretty straightforward because it's just X and Y, but in a normal question, your variables probably won't be called X and Y. They'll have actual names. So make sure to put your EV where your EV needs to go, which is your X variable, and your RV, which is your Y variable. So in this case, just X and Y. Everything else can stay exactly the same. And then you just press on OK, and then you'll see it performs a stat calculation, and it gives you a whole host of information. Now, the only piece of information we're looking for is this one right here, the R value, the Pearson's correlation coefficient, the R value, which is this one here. So we've got this number here. Clearly, it's got a lot of decimal places. We need to round it to 2 decimal places. So hopefully you can do that, which should be 0.83. So R value should be 0.83. And going by the table that we spoke about previously, as the R value is positive, it indicates that the linear association between these two variables is a strong positive linear association. Thanks again for tuning into another video brought to you by RouTube. Feel free to like and subscribe if you learned a thing or two, and please feel free to check out my other videos relating to data and anything else. Catch you next time.